Good morning, Year 12 candidates, and once again, welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And in this video, I want us to discuss intersections of straight lines and circles. And of course, we are going to see at least two types of straight lines that intersect the circles. In fact, three types, because you may talk of a circle like this, and you may have a line that touches the circle and moves. This is a point of intersection. Of course, we know this is a tangent. We all know that line as a tangent. A line might intersect the circle once, and that line is obviously called the tangent. A line may intersect the circle twice. These are point of intersection, this point and this point. And you can already see that this is a chord of that circle produced such that it intersects the circle at that particular point, and this other point. These are points of intersection, point of intersection. And you could be having another line that does not touch the circle anywhere. Of course, this line, if it doesn't touch the circle, it does not intersect the circle, then the equation of that line will never rhyme, or will never be compatible, or will never fit in the equation of the circle. This will fit in the equation of the circle once, and this line will fit in the equation of the circle two times. Of course, you can see it intersects the circle twice. And I want us to say something which is written in bold on page 33. A straight line can intersect a circle once by just touching the circle, like this one, or twice. And of course, you are advised that not all straight lines will intersect a given circle. This one does not. And we are going to look at example 8. Example 8 talks of find the coordinates. Find the coordinates of the point where the line y is equals to x plus 5 meets the circle, which circle? X squared plus y minus 2 squared is equals to 29. Find the coordinates where this line meets that circle. What we are expected to do is to substitute one equation into the other and find out if it makes sense. If it makes sense, then the coordinates of the point of intersection of the straight line and of the circle will always be the same. So at the point of intersection, x is equal for both the straight line and the circle. And if we have a second point, then the second x will be the same for the straight line and as well as the circle. So in this one, now that we know this is y is equals to x plus 5, and the equation of the circle is x squared plus, if we say y is equals to x plus 5 and call this equation 1, x squared plus y minus 2 squared is equals to 29, and call this equation 2, we can easily say substituting 1 in 2. That is the best thing we can do. We solve simultaneous equations because they are. We solve simultaneous equation by substitution method. So we're going to have x squared plus y is x plus 2, x plus 5 rather, x plus 5 minus 2. This part stands in for y. This is squared is equals to 29. Of course, it goes without saying that we're going to have x squared plus x plus 3 squared is equals to 29. And that is just like it. The only business we have here is simply to expand this, and we have x squared plus x squared plus 6x plus 9 is equals to 29. Having said that, x squared plus x squared is 2x squared plus 6x, of course, minus 20 is equals to 0. Now it is a perfect quadratic equation, and even before we go further, we can divide everything by 2 to have x squared plus 3x minus 10 is equals to 0. So at that point, we can solve this quadratic equation using whatever method. But let us try factorizing method, and we talk about B and AC. Our B is 3 and AC is minus 10. Which two numbers we multiply, they give us a minus 10, and we add them, they give us a plus 3. This is obviously a plus 5 and a minus 2. So x squared plus 5x minus 2x minus 10 is equals to 0. So at that point you have x plus 5 minus 2x plus 5 is 0. So at the end of the day, you'll find that x is equals to 2 or x is equals to minus 5. What does this mean? What does this mean? It means it is possible that this particular line intersects the circle at two different points, when x is equals to 2 as well as when x is equals to minus 5. So let us maximize and believe that it is not a tangent, because a tangent touches the circle only once. It is a chord which is produced, and therefore it intersects the circle twice. So when x is equals to 2, y is equals to, now we can substitute this in equation 1 because it's easier that way. Y is equals to 2 plus 5, which is 7. So it is possible that the line y is equals to x plus 5 intersect the circle at the point 2, 7. And when x is equals to minus 5, y is equals to minus 5 plus 5, which is 0. So it is possible again that the line intersects the circle at point minus 5, 0. So that is just right like it, and we have been able to establish the 2 points where the line cuts the x-axis. No, not the x-axis, that the line y is equals to x plus 5 intersect the circle, and that is just what you are required to do. Please remember, we were faced with two simultaneous equations, one linear and one nonlinear, and the best way to solve them is by substitution method, and that is what we have done. So please again visit my YouTube channel, subscribe, and let us work together. All right.